Hello, I'm going to be demonstrating how to connect this network together. This network is consisting of 4 VYOS routers, and each one of the VYOS routers will have a loopback address attached to them. All the VYOS routers, with the exception of branch office 3, which is at the bottom, will have a single LAN interface with a single device connected to them. The devices in question are what they call micro XP clients, and these clients can be downloaded off the internet. They're not a full Windows operating system, they're only partial, but they're perfect for testing continuity. WinXP1 is there just for additional connectivity. The main area that I want to discuss here is between WinXP3 and WinXP2. The WAN is consisting of a partially meshed configuration, and for the purposes of this exercise, we're going to envisage that these links are going to have different speeds associated with them. I'm going to leave this diagram up for a minute or two, or a minute, just so that you can actually grab a snapshot to make it easier for you to go through. As I go through the configuration, might be easier for you to follow. Okay, let's get started. As there is a fair amount of repetition in this network, and to keep the video as short as I possibly can, I'm going to configure a site and then put the video on pause, and then go and do the other sites and then come back. So we're going to start off with the head office. What we're going to do on the head office is put a loopback address. The loopback address of head office is 1.1.1.1, and we're going to put on the LAN. So at the moment we've got this WinXP, which is WinXP3. It's connected to the head office, and as you can see, I've already put an IP address on it and of 10.0.0.1, and I've already pinged it, as you can see, and was successful. So if I try and ping the gateway, you'll see that I can't at the moment, and you see that I won't be able to ping the loopback for that gateway either because they're not configured yet. Oops. So I'll go down and configure the head office. So as you can see, I haven't got any interfaces. So Ethernet 0, and no interfaces at all on this device. Ethernet 0 is the LAN interface that connects to WinXP3. But the first thing I'm going to do is configure a loopback. So I'm going to go into conf mode. And I'm going to set interfaces loopback hello, which is you only have a single loopback on the VYOS. So I'm going to put on a description. Now, when you put on a description, if you're using a multi-word description separated by spaces, you're going to have to use quotes. You can use other, like an underscore or a hyphen if you don't want to use a space, you don't want to use quotes, but it's easier just to use quotes. So I'm just going to put link to WinXP3 and commit, just so that you can show. If I exit out now and I could just show you the interface now, you can see that I've got a comment obviously down at loopback 0. I'm putting an IP address on it, so I'm going to do that now. So you can just use the history, it's got a history, so you can just go and up tab and then just set the address. You can just do auto completion tab, just like with any other devices, any other network devices that you're used to. You use the /2 quote. You don't use you don't specify explicitly the subnet mask. You just obviously do the bit length. So now, if I do a show int, you'll see my loopback address now has an IP address associated with it. So I'm going to go ahead and do eth0. So at the moment, eth0 is connected. I've got all this VYOS connected in a VMware environment, and the VMware environment at the moment, the networks are set up as access, set up in access mode. So I just have to put a straight IP address on the actual interface itself. But if the interface happened to be a trunk, then I'm just going to show you very quickly how to configure tagged interfaces. Because this is a router, we're using the router would use tagged interfaces. The router would actually, unless it was operating in bridge mode, the router would de-encapsulate the packet that hits it on this interface and then re-encapsulate it on another VLAN or whatever. We're not operating in bridge mode, so the VLAN interface, it's not really a VLAN interface going to another interface in the same VLAN. So it's tagged. So this is the command if you're going to want to set a tagged interface. So set interface Ethernet 0 Ethernet eth0. So it's the same as what you would with the others that I've explained earlier, but in this particular case you'd use this command, which is VIF. Some people call it VLAN interface, but because we're operating in routing mode and it's tagged, I tend to think of this as a virtual interface. So if you looked in the diagram, you'll notice that E0 actually corresponds to VLAN 2001. So you'd put 2001 there if this was an actual trunk interface, and then you would set your normal commands as usual. But because this isn't a tagged interface, this is just a straight access interface, I'm going to set the address as 10.0.0.254 with the subnet length, which is 24, and I'm going to give it a description. Oops, I put the wrong description on the loopback, so never mind. Section link to XP3. Okay, permit. Actually, I might actually set that loopback address to the right. It's not linked to WinXP3, it's loopback. Okay, commit and save. Okay, exit, show int. Okay, so we have our loopback and we now have our WinXP3 interface. So if I now go here and ping 1.1.1.1, now I can ping it. The reason why I can ping it is because the router that we just configured has a connection to WinXP3, it's a direct connection, and also a direct connection to 1.1.1.1, which is the loopback. So it's able to reach both, so it's able to transfer packets between both 1.1.1.1 and 10.0.0.1, which is WinXP3. So I'm going to go and configure the rest of the interfaces. So I'm going to pause the video at the moment. Okay, now that I've completed the configuration of the other devices, I'm going to see what I can see. If I try and ping 2.2.2.2, it doesn't work. The actual gateway is telling me it's unreachable. It'll be the same with all the others. And why is that? It's because I haven't actually configured any WAN interfaces yet. So I'm going to do those now. I've already configured the WAN interfaces on all the other devices, so as soon as I begin to configure these, we should be able to start connecting to them. So I'm just going to start by connecting to ETH1, which is the link to branch 1. So I'll go to conf mode again, and I go set interfaces Ethernet ETH1 address. I already put the description in, so I don't need to do that. The IP address for this is 192.168. So 192, not 92, 192.168.50.1/30. I'm using a point-to-point interface. If I commit, and I save, exit. So if I try and do a ping to 19, the other end, which would be 192.168.50.2, as you can see, I can reach it. And just to make sure, if I just do, you can do an SSH from a VYOS. This is a command to do it. It's actually it's the standard Linux command or Unix command. 192.168.50.2. So what it is, you put the username and then the @ and the target. Because I've not logged on this before, it's asking me if I want to accept the credentials. I'll say yes. And so you can see I'm now on branch office 1. So I'll just exit out of that. So you can see I'm connected already. I'm back on head office now. So I'll do the next one, which is Ethernet 2, and that's, so if I go and conf back in and set Ethernet 2, and the IP address of this guy is 5, which is the next point-to-point subnet available. And then I'll do Ethernet 3, which is .9, which is the next subnet available. Okay, commit, exit, show int. Okay, that's there. I forgot to put a description on Ethernet 3, so I'll just do that to make it clean. Insert Ethernet 3 description HQ to branch 3. Commit. You always commit every time and save your config, especially on these ones, because these are virtual devices. Okay, so what I'll do is then I'll run the same command. I'll SSH to the others just to make sure. So I'll go to 6, which is the other end, which should be branch 2, which is it's branch 2, as you can see, and then .10, which is the other one. And that's branch office 3. So I've got point-to-point connectivity, and obviously you can see that I configured the other ends, otherwise I wouldn't be able to get to them. Okay, so with that in mind, now that we've got WAN connectivity, are we able to reach any of these other loopbacks? No. So obviously the reason for that is, although we've got connectivity locally, we haven't got any routing protocols in place in order for them to be able to reach back. We can get to them, but they can't get back to us. Oh, right, sorry. We can't get to them on the loopbacks. We can't get to them on any other interfaces except the WAN interfaces, which are directly connected. So we need to add some routing in there now in order to make that happen. Okay, so now a lot of people probably be saying, well, this is a fairly simple network. Why don't you use static routes? Okay, so we'll use static routes. Okay, I'm going to bring back up the diagram, because in this we're going to make the assumption that the link, so we're going to concentrate mainly on head office to branch office 2 connectivity. I'll put the other connectivity in as well, but for this purpose of static routes, we want to assume that head office, to get to branch office 2, the best route would be via branch office 1, because let's say that's got a 1 gig link. And then, although it's directly connected on VLAN 1002, let's say that that's only a 100 meg link, and so that's going to be our next best route. And then branch office 3, being a 10 meg link, will be our least preferred route. So what we're going to do is we're going to configure the static routes so that the best route will be via branch office 1. So I'm going to configure that in now. So go back to head office. So conf. Okay, to set up a routing protocol, I don't regard a static routing as to being a routing protocol. I regard it as being a routing mechanism, but it's under the protocol. So in order to set, so let's have a look again. Let's just do a show interface. Oh, sorry, I'm in wrong mode. Let's just exit out. Just do a show int. So we're going to make Ethernet 1 our primary route, 3 branch 1. Ethernet 2 is going to be our secondary, and Ethernet 3 is going to be our alternate. So let's go back into conf mode. And to set static routes up, you just set protocols, and we're setting up static routes, and then we put in where we want to go to. So the networks that we actually want to go to, if I move this to the side a little bit, the network destination, let's just do, so we'll do branch office 2's loopback, which is 3.3.3.3, and the 10.2.2.0 network. So let's put those in first. So bring that back up. So target will be 10.0.0.0. Oh, sorry, 10. Sorry, my mistake. Let me just take a look at that again. Move that to the side. Yeah, it's 10.2.2. So 10.2.2.0/24. And the next hop, oh sorry, I need to put in route. Right, 10.2.2.0/24. And the next hop will be 192.168.50.2, which is the address of that top, branch office 1. And obviously we want to do the same thing to the loopback address. So, and the loopback address is 3.3.3.3. Oops. Helps if I put dots instead of this. Sorry, I put commas instead of dots. Oh, hang on. Help if I put in this. Okay. Right, okay, so we've done that one. So the next one we want to do is we want to do the same thing again. So, but this time we want to go to 6. But we then want to set a distance. Distance, well, let's call this 10. And we want to do the same thing with 3.3.3.3/32. And then the last one, we want to set the distance as being 20 to go via 10. So that means we go by 10 and our distance is 20. And if we do the same thing with 3.3.3.3/32. Commit. Save. Exit. Okay, if we do show route, I think it's show IP route, you can see now that we've got a number of different routes, but the one with a star on it is the preferred route. So as you can see, the preferred route to 3.3.3.3/32 will go via Ethernet 1, which is our link through branch office 1 to get to branch office 2. And the same if you look at 10.2.2.0/24. Even though there's 3 routes, the preferred route is the one that's going via Ethernet 1, which is exactly what we want. Okay, let's go and see if we can reach it. So we'll win XP3. So ping 3. No, it's still unreachable because although we put a static route on there, and you'll notice now that it's not reply from 10.0.0.254. It's the reply from 192.168.50.2, which is branch office 1 telling me that I can't reach it because I haven't put any routing on that guy yet. Although we put routing on head office, we haven't put routing on the other guy. So I'm going to pause the, obviously I'm going to now do the same things on all the other routers, and I will come back. Okay, now I've configured all the other devices. Now let's go and see what we can see. So I'm back on WinXP3. So if I try and ping 10. So ping 1. We already know that we can get to 1.1.1.1. So try 2.2.2.2. Okay, now we can reach that's branch office 1. Try 3.3.3. 3.3.3.3. That's branch office 2. And ping 4.4.4.4. branch office 3. So if we try and reach the other XPs on 10.1.1.1, yep, we can win that one, and 10.2.2.1, yes, we can reach that one. Okay, so let's so one of the downsides about using static routes, if we go and have a look at head office, for instance, and I exit out there and I do a show IP route, you can sort of see that we've only got a couple of networks in there, but then the routing table is already starting to look big. Not so much that, but if you just do a show conf com and then just look up match static, this shows you all the configuration associated with static routes. We've only got a couple of routes, basically 2, 3, 4 routes in there, but already that routing table, the configurations start to get big. Imagine if you've got, I don't know, 100 routes that you need to put in, and then that you can't summarize into larger subnets. You'd have to stick 100 routes manually in each router. Because it's local, you have to do it on each individual router. And if you've got, like what we've got here, we've got 3 links going to the same one, you're effectively tripling the number of routes that you're going to put in your configuration, which gets a bit unwieldy. And it can be a bit problematic for troubleshooting purposes. So it's one of the things that I don't like about static routes. Okay, so let's go and see, so do a show IP route. And the one of interest, let's say we want to look at the loopback. That's loopback 3.3.3.3/32. Hopefully you can see that there's 3 routes there, and obviously the best one is going via 192.168.50.2. So what we can do here, I'm going to simulate that we've got a link down on this guy, branch office 2, on the primary link. So that's the one I'm going to do. So I'm just going to manually shut it down for the moment. So I jump onto branch office 2 and just do a show interface, make sure that I get to the right one. I don't want to be shutting down the wrong one. Okay, so I'm going to shut down branch 2 to branch 1, which is effectively that leg with the high speed. So I'm going to go conf. Now to disable interface, it's basically that's what it is. Delete set interface Ethernet ETH, and the one I want to shut down is ETH1 disable. Okay, and then you have to commit. Right, I've just committed that. Now let's just shut that down. Okay, so let's go and see if WinXP3 can still reach the network behind it, which is 10.2.2.1. It can't. Now, why on earth is that happening? So let's go and have a look at branch office. Let's go and have a look at the head office and see if it's picked an alternate route. Show IP route. It's still seeing that route, so show IP route 10.2.2.0/24. It's still seeing that route as the best, even though we've shut that down and quite clearly we can't reach. There's obviously a problem. It's using that route even though that route is not available. So if we actually go and have a look at the other side, so if we jump onto branch office 2 and do a exit out of that, show IP route. IP route now for 10.0.0/24, going back the other way, it sees that it via 192.168.50.13, which is the link that goes up to branch office 1, as being inactive, and it's now chosen the second best path, which is 5. But why is the other one not following suit? Why is head office still trying to use that link? Why is it seeing that link via branch office 1 as being the best route? Now this is one of the problems with static routes. That's the reason why I don't like using them. So basically, let's have a look at what the route is saying. Well, I've got a static branch office, head office 1 is saying I've got a static route to branch office 1. How do I get, to go to 10, let's say 3333. I've got a route for 333, my primary route is going via branch office 1. I've just disconnected the link between branch office 2 and branch office 1 by shutting down the interface on branch office 2. Branch office 2 understands that that interface is down and now uses the secondary interface, which is fine, which is exactly what it's supposed to do. Branch office, head office though, is not. And the reason why is because the static route first turns around and does a sort of thing called recursive routing. So everything happens in a recursion right down until it hits a connected interface. So what it's saying is, how can I get to branch office 3.3.3.3? It says I can reach it by static routes via branch office 2.2.2.2. Via 192.168.50.2. That is my next hop. How do I get to 192.168.50.2? I get to it via my Ethernet 1 interface. Is my Ethernet 1 interface down? No. That route is still valid. It doesn't look at the end-to-end. It only looks at the local. It recurses all the way down to the connected interface. And if that connected interface is available, it will not bring it down. So let's simulate that by bringing it down. So I'm going to go on head office, at the head office, show int, and I'm going to bring it down. So it's the branch is going to eth1, so I'm going to do set conf set interface Ethernet 1 disable. Commit. Now exit. Let's do a show IP route and see how we can get to 3.3.3.3/32. Now the static is going via eth2 now, which is going the right way. So it's now seeing the primary route as being inactive. So if we now go to this guy, you can now get back to it. Now this is the reason why you should, well, it's your choice whether you use them or not. I never use them. I only use them if there's no other way of being able to set it dynamically, even on the simplest of networks. I do not use static routes for this reason. So you can see now that is a bit of a problem. So, okay, so we've now got, it's now running through the secondary route, which is fine. And let's go now and shut down. Let's go to branch office 2 again, and shut down the second interface. So show int. So it's down. So the next one is Ethernet 2. So we just do the same thing. Set Ethernet 2. Disable. Commit. Now this is directly connected. So let's go and see how we're getting on with WinXP3. I can't reach it again. Interesting. Okay, so if I exit out there, just do a show IP route. Right, let's have a look at the one for 10.0.0/0/24. And to get and 1.1.1.32, which is obviously the way back, it's using 192.168.50.17, which is via E3, which is via the low speed interface, which is the final interface that we've got, which is correct. Let's jump on head office 1, just do a show IP route. So we're interested in 10.2.2 and 2.2.0 and IP just okay. So if we look at 3.3.3.3/32, it's still going via 192.168.50.6 Ethernet 2, even though we shut the directly connected other interface down. Right, this is another problem. Even though we're directly connected, we're not directly connected. We're actually connected via an Ethernet network, which is a carrier sense multiple access network. Which means, in this particular case, I'm using a virtual switch to get these two together. But in the normal circumstances, you'd have multiple machines connected to the same VLAN. Even though we're using a point-to-point address, it's a broadcast LAN, and it allows people to just drop in and drop out. You know, people go home from work and they disconnect their device. It's not going to bring the network down. It's the same thing in this particular case. Although we've shut down the interface on the far end, they're connected to a virtual switch. The virtual switch isn't down. That means the Ethernet interface on head office 1 isn't down. And like I said before, it recurses back to a connected interface. And although their next hop, which is 192.168.50.6, is down, the method it connects to it is via its Ethernet 2 interface, I believe, is up. So the static route still treats that as valid. We'd have to take the whole switch down in order for it not to become invalid, or we'd have to directly connect between the two hosts using an Ethernet cable, a crossover Ethernet cable. So happens a lot in sort of environments where you have virtualization and you have or you're connected via Ethernet interfaces. I mean, in the past, serial interfaces use a layer 2 protocol to detect whether a link is up or down or not, regardless of what it's connected to. In this particular case, it doesn't. And that's the reason why, again, static routes are very, very dangerous to use in Ethernet type environments or in a virtual environment. So it's one thing to be very, very careful about. Okay, so obviously static routes don't work in this particular case. So we'll look at a dynamic routing protocol next. I'm just going to pause the video. Just to show you, if you've got static routes everywhere, just before I pause the video, if you've got static routes everywhere, or you've got static routes, so you can get rid of static routes simply by all of them, just by doing this, conf, and then you can just do delete protocols static. You don't have to put anything else in, everything underneath that will just go. And if I commit that now, and I exit out of that, and I'll just do a show IP route, you'll see there's no statics, they've all gone. So if you're taking away a protocol completely, you don't have to take out every individual line you added. You can just take it out from the branch of that point, and all the sub branches will just disappear. Okay, I'm going to pause the video now, just clean everything else up and get it ready for the dynamic route. Now we're going to use a routing protocol between a dynamic routing protocol, proper protocol between all the Office VYOS routers. So the protocol of choice in this particular case is OSPF, and I've already took the liberty of configuring Branch Office 1, Branch Office 2 and Branch Office 3 with OSPF, so that when I configure the head office you'll see it come up straight away. As with the static protocols, we're going to configure OSPF in such a way that the cost is not going to load balance between them, because that's what OSPF will try to do if possible, but to establish a primary route through Branch Office 1, secondary route through the direct link between Head Office 1 and Branch Office 2, and Branch Office 3, and the alternate route via Branch Office 3. We use a process called OSPF costs to do this, which is configured on the outgoing interfaces of each of the routers to add up the costs. So I'm just going to show you one of the other ones that I've already got OSPF configured. So on WinXP1, the default costs, by the way, on all LAN interfaces is 10. So in the case of Branch Office 3, I'm going to jump on Branch Office 3 to show you the costs that go through to WinXP1 so you can understand how the costs are configured. So on Branch Office 3 at the moment, I have an outgoing OSPF cost. I'm not sure what I put actually, so I'll just jump on there and find out. Show conf. I just want to look for the costs, so I'm just going to do a match on the cost. Okay, so I've set both interfaces to have a cost of 20. So the cost going out, so the cost out is this interface will be 20. And if I jump on Branch Office 2 to have a look at the cost that's going up here, so Branch Office 2, so do the same command, show conf match cost. Show should be show conf show conf match cost. So the outgoing one that we're actually interested in is Ethernet 1. So that's got a cost of 5. So the cost so far is 20 plus 5, and I've already configured an outgoing cost on here of 20. So that cost to get from Branch Office 3 to the 10110 network should be 25 plus 20, which is 45. So let's go and double check. So if I do a show IP route, I've already done the show IP route this, so I'll just pull that over. So the one of interest is a 10220. It doesn't show, so show IP route. Show IP route 1.1.0/24, and the cost metric is 45. So the costs are, you can artificially make the costs the way that you want them to. Okay, so if you notice, show IP route 10.0.0.0, it's not in the table, or 1.1.1.1 for instance, because I haven't set OSPF up yet. So I'm going to configure that now on the head office. So head office. So the way to set this up, so conf, so set, it's protocol, so you're going under the protocols left, and it's OSPF. And the first thing that you need to do is to go into parameters and set a router ID up. Now in this particular case, because we're using loopback addresses, well, easily identifiable, we're going to use that as our router interface, our router ID. Now the next thing that we're going to do is to set up the area parameter. Area. I'm using the default 0.0.0.0. Now, what we should be doing here, to make this proper, we should be putting each one of these networks in as separate networks. So 192.168.50.0/30.4-30 and 10.0.0.24 and 1.1.1.1. But the lazy way to do it, if you wanted to configure this really quickly, is you could put in this network 0.0.0.0/0. If we committed this, it's perfectly fine. Now what you'll see, if we jump onto one of the other routers, let's do branch office 2 for instance, show IP route 10.0.0.0. It's not there yet. Give it a second. Still not there yet. Ah, it's not there yet. Oh, it should be there. Hang on, let me just find out. Exit. Show IP OSPF. It's there. Show IP OSPF neighbors. Not in there. I've just realized what the problem is. I've changed the timers so that I can make it faster on the other devices. So I need to do the same thing here. If the timers do not match, then it won't form adjacency. So I will do a show conf com match cost. That's a match OSPF. Show match. Actually, I'll just do a show IP route. Show IP route. Look at my directly connected interfaces. So I'm using Ethernet 1, Ethernet 2 and Ethernet 3. So I need to put costs on each one of those interfaces. So I will add these in now. So I'll just do conf. So I'm going to set interface Ethernet 1, and I've set the IP OSPF timers. It's just so that they converge quicker. The OSPF timers, OSPF. So dead timer I've set for 10. I've set the hello interval. I'll do it on all the other ones as well. IP OSPF hello interval 5. Sorry, hello interval is 2. So I'll just do Ethernet 2 and Ethernet 3. And I'll do dead interval I've already set for 1, set it for 2, set it for 3, and then I will set retry interval 5, do it on some of the others, 2, 3, and I set the retransmits interval transmit delay for 1. Okay, so the timers all match up now with the other sites. Commit, save, exit. Okay, see if I can find any neighbors. IP OSPF neighbor. Okay, they're forming adjacencies now. Okay, so if I go back to branch office 2, so I'll just run a show IP route again. So I've got it going via Ethernet 1, which is the way that I want it to go. I haven't set the costs up. I've set the costs up in that direction, but I haven't set the costs up in the head office direction. So this might, so if I do a show IP route in the other direction for 10.2.2.0, I'm going by the direct route, so I need to change the costs. So obviously OSPF is choosing the cost because I haven't set the costs, it's using the defaults. And because this is the middle one has got a direct route, which is not what we want, it's got a lower cost. So I need to actually change the costs. So I'm going to do that now. So conf, and I'm going to do a set interface Ethernet ETH1 IP OSPF cost. I'm going to make that cost, I think I made that cost 5. So I'm going to make that cost 5. I'm going to make Ethernet 2, I'm going to make that cost 20. And I'm going to make Ethernet 3 cost also 20 because that's 2 hops. And I'm going to commit and save. Okay, now if I go and have a look at the show IP route again, I'm now going via the way I want to go because the simple fact is that's the more efficient route. So let me go and run a continuous ping on this guy. I'm going to ping all the way through to 10.2.2.1, but I'm going to make it continuous. Okay, so that's running, and now what I'm going to do is I'm going to shut the interface, what we did before, branch office 2, I'm going to shut the interface down, so show int, I'm going to shut the interface the same way as I did it before. So if I'm going to do a conf, I'm going to do delete, set interface Ethernet ETH1 disable, commit. And what will happen, what's probably going to happen, I might lose a ping or two. I didn't even lose a ping, it reconverged and just took a little longer to send it. So now, if I go and have a look on the branch, the head office, now remember when I did this with a static route, it dropped out completely. So the show IP route, show IP route, I'll just show IP route to 10.2.2.0. Now you can see now it's using Ethernet 2. That's the direct link, which is we've made the costing so that it's the next best link, which is great. You'll notice that it's not picking the other one, even though the connection is still up to branch office 1. It's not actually the router, the head office router that's making the decisions. It's actually branch office 2 that's making the decisions on how the routing has been affected. So it's totally a protocol because it's an agreement between all the routers on which route is valid. Okay, so that's still going. So why don't I go back to head office 2, branch office 2, and then set the other one to be disabled. And commit. Now the other one's just dropped. So let's see what's happening here. You can see there was a bit of there, you had an 8 millisecond, 6 millisecond display, and then it just went back to normal. So nothing has changed. It's now should be using the third route, which it is. It's now going via Ethernet 3. If we just go back to the other one and bring back the primary interface. So let's bring back the primary interface. Delete. Commit. Okay, now the primary interface should be back up. Let's go and have a look at what's happened to my pings. Yeah, we had a bit of disruption, 8 millisecond No, there's a 3 millisecond one there as well, but we haven't lost a packet. So let's just go back to branch head office. And let's go and have a look at the routing table now. Now it's going back via Ethernet 1. So as you can see, dynamic protocol works perfectly. Works out the box. I haven't done anything fancy. I've just set OSPF up on all of them. If you look at the configuration, let's look at the configuration of branch 2. So if I exit out of there, just do a show com match OSPF. We have a little bit of config. It's not going to get any bigger than that. The only differences will be if you want security, you'll add MD5, checksums on it so that it doesn't try and connect to an OSPF neighbor. It's trying to sneak its way in. You just add the routes, and the only issue that we've got here at the moment is obviously on the head office. Show com match OSPF. You'll notice that we're just using a single network that encompasses everything. Now that will work fine, but it's probably not a good idea. I'll give you an example of the reasons why. Say for instance, each one of our branch routers, we've got a whole bunch of networks behind them. So let's say we use the 172.16.0.0 network, and we subnet it into 3 subnets. The first subnet, let's say they're all /22s. So the first 4 subnets of the 172.16.0.0 network would go to branch office 1. 172.16.4.0/22 would go behind branch office 2. 172.16.8.0/22 would be serviced behind branch office 3, and you've got them all set up all nicely. And on the head office, you accidentally use one of the, let's say for instance you put in an interface and you give it 172.16.3.0/24, you're automatically overriding routes that you've actually given to branch office 1, and that route would be then directed towards you instead of being directed towards it. You just accidentally put the interface on by mistake, but because you've got this 0/0/0/0/0/0 network, any interface that you actually put into that particular router will get injected into OSPF. The other thing as well is you might have a couple of networks attached to, let's say, branch office 1. They might be a research and development division, and they wanted a couple of networks to be on there, and they just want to be able to talk to each other. They don't want to be able to talk to anybody else. You automatically, if you had a 0/0/0.0.0.0/0 network, you would automatically incorporate them into the OSPF networks when you might not have wanted them to be in there. So it's not a good idea using OSPF blanket coverage. So I'll go and change that. So let's conf, and then just do a delete protocol OSPF. If you just want to get rid of OSPF, everything off there, you just do that. But we don't want to do that. We want to delete just the area 0.0.0.0. We can just do that. Actually, I don't want to do that. So I'll do that. So and then I'll just do a set protocol OSPF area. I'll do 192.168.50. I will do a /32 on this, which will cover all my directly connected interfaces on the WAN. It doesn't matter that I might be using a subnet that actually encompasses networks between Ethernet, between branch office 3 and branch office 2 and branch office 1 and branch office 2, because it only advertises local networks. So only networks that come in within this range will be advertised by this router, so it's not a problem. So so that's encompassing, I just want to encompass say 32 addresses, so I put in here, what's that, there's going to be 30, 29, 28, 27 slash 27. Oops, I need to put the area number. Network. And that covers that. I also want to put in my 1.1.1.1/32, and I also want to put in my 10.0.0.0/24 and commit and save. Okay, let's just make absolutely sure that my networks that I've covered are still going to be seen. So if I just do a show IP route 1.1.1.1, yeah, via Ethernet 1, which is the one I wanted to. Oh, actually, show int. Let's bring them all back up because I know one of them's down. So conf set interface Ethernet. Oops, sorry. Delete interface Ethernet 1. That's 2 actually. Disable. Commit. Save. Exit. Show int. Okay, they're all up. Show IP route 1.1.1.1. Still going via ETH1, which is what we're expecting. 10.0.0.0/24 via Ethernet 1. I'll just show IP route. You'll see that you can see directly connect. So you can see the 192.168.50 networks, and you'll see that you can see that via OSPF, but that's not being used on most of them because the connected ones always win out. So 192.168.50.4 /30, for example, because it's directly connected, it will always win out on the OSPF, but the OSPF one will already be there as well. You'll notice one there, 192.168.50.8/30, is only known by OSPF. It's because it's not directly connected to this router. It's connected behind branch office 1, it'll be branch office 2 actually. Branch office 2, sorry, branch office 3, it's behind branch office 3. So, yeah, there you have it. So, and this is far more robust. It's more predictable. It's much more predictable than static routes. So, and that's the reason why I always choose a dynamic route over a static route any stage. Okay, that's really all that I've got to talk about, really. I hope this has been informative. Please post a like if you found this useful to yourself, and if you want to see any more upcoming videos, I suggest that you subscribe to my channel, and then whenever I'm putting out new videos, you'll be able to see that. Thanks very much for watching.